So we're going to resume with delta table operations. You can always pull up the index by clicking on this 3-dot and bar menu. We're going to start from here, and we're then going to continue to the end. You can close it by clicking here or here. What I just did is I clicked on runtime, run all. What that's doing is it's executing all this code. The items that get executed, you're going to see check marks next to. And this is, so there's a newer update, so it's downloading. You see the output right here. So once this is executed, you'll see all the code, but we're just going to resume, and by the time we get to it, it should have executed. So coming back to delta table operations. All right. In delta table operations, we are in the right place. Yep, we go to the code segment. All right. So first we have the imports, right? What are imports doing for us? They are bringing in, star from delta tables, right? And they are bringing in star from PySpark SQL functions. So delta table modules provides us the delta table API, and the PySpark SQL module, PySpark SQL functions module gives us all the functions which are used for performing data transformations and manipulations. Now note that this is still running. Delta table, this command right here, this line creates a delta table object, delta table, right? Delta table, this is the class. It creates an object, delta, or we don't necessarily say classes anymore. It's methods now. Object delta table by pointing to the existing table located here. Then the update command. We are doing an update when this condition is met. We are setting the update to something. We are basically updating every even file, every even instance of ID. We update that, we add a certain value to it, then we do a deletion. We delete the cases where the condition is that every single ID is even. Then we do an upsert. All right, let's keep it here so we don't get mixed up in our output. In the upsert, we are merging new data. The first line in the upsert, new data equals spark range 0 to 20, creates a new data frame, new data, containing the range of integers from 0 to 19. Then we print that. We are doing new data dot show. To show what the output is, then we're doing print show table. Now you notice the output's showing up. That's because we have now gotten to this code block. If we come up here, you'll see check marks where we've got the output. And here, this guy is executing, so we are seeing the output as it is. And the last part of the output is going to show up as soon as it executes, which should be momentarily. And that's how simple it is. You've essentially got a computer to yourself, or more or less a supercomputer. There we go. There is a final output. And the rest is executing. So we'll have the full output soon. And this was achieved by going to runtime, run all. All right. So we are at delta table alias. Delta table alias, new delta table alias old data. So what this block is doing, this block of code performs an upsert, which is a merge operation on the delta table, merging the new data frame with the existing data. Then the alias method is used to assign aliases to the delta table old data and the new data, which is new data. The merge method initiates the merge operation, comparing the ID column from both databases, right? We use the upsert method because it combines an insert with an update operation to improve data integrity and simplify any potential rollback. For additional documentation, you can go to the upsert details, which are up here, which we've already talked about. All right. And in the case where we have matched updates, we are setting the ID to, to new data. And when there are no matched updates, we are inserting the value of the ID, right? So when matched, update. When not matched, insert. And then execute is run the whole code, and then the final show gives us this output. So we had values from 0 through 9. Excuse me, we had prior values. We added and inserted everything that wasn't there, and this is our output. Okay. This is output. The rows have been inserted. All right. So querying a specific version of the Delta table. This is called time travel. This is a very useful function. All right. For this part, this code demonstrates how to query a specific version of a Delta table using the Delta Lake library's time travel capabilities. What are the steps? We first read a specific version of the Delta table. The df spark read format Delta option version as of, and then load this table. This line reads data from the Delta table, temp Delta table. The read method is used to initiate the reading process. Format Delta specifies that the data should be read from the data lake table. Option version as of, and then 0 sets the version as of option to 0. Which instructs Delta Lake to read the data from the initial version, which is version 0 of the table, and then load from this location, loads the data from the specified path. The resulting data is stored in the DF, which is data frame, and then we do a data frame show, the output of which is here. So by using the version as of option when reading the data table, you can query a specific version of the table's data. In this case, version as of 0 retrieves the initial value of the table, which corresponds. It's pretty simple, right? And the time travel capability provided by Delta Lake is particularly useful for auditing, reproducing results, or reverting to a previous state of the data if needed. It leverages Delta Lake's transaction log and data versioning features to maintain a history of the changes and to make previous versions of the data, accessible. All right, now going to the next code segment, writing a streaming data frame. All right, and this is right here, and data frame show. There we go. All right, writing a streaming data frame. Just want to make sure. Read format, we just did this. Yes. Okay. Yep, exactly. Thank you. Writing a streaming frame. Here we go. All right. So this code demonstrates how to write a streaming data frame to a Delta table using Apache Spark's structured streaming capabilities and the Delta Lake library. So what are the steps? First step is to create a streaming data frame. Streaming df equals Spark read stream format rate, and then load. This line creates a streaming data frame, streaming df, by reading the data from the rate source, which is a built-in source that generates a stream of data at a specific rate. Transforming the streaming data frame, this line stream equals streaming df select expression, and then value is ID. This line applies a transformation to the streaming data frame by selecting the value column and renaming it to the ID. All right, we select the value and rename it to ID. And let's see, then we do a write. Oh yeah, and then option start. Then we are writing, so gstream, excuse me, here we go, gstream, option, yeah, value as writes, got it, yeah, writes right here, write stream, exactly. Okay, so you see, the code is read left to right, and the functions are right here. So in this, method, use this expression, using this method, this format. I mean, it's a command inside of a defined command class, so to speak. All right, so the stream equals, we were at the writing part, which is right here, write stream format Delta. So for write stream, put put this in the right place. Here we go. The write stream method is used to initiate the streaming write process. Format delta specifies that the data should be written in the Delta Lake format. And the option checkpoint location sets the checkpoint location for fault-tolerant processing of the streaming query. And then start temp delta table starts the streaming query. Start delta table, yeah. Starts the streaming query and writes the data to the specified delta table path. The streaming query is assigned to the stream variable for later reference, so this will be our variable that this whole expression evaluates to. By writing the streaming data file to a Delta table, you can take advantage of Delta Lake's features such as ACID transactions, data versioning, and efficient storage and retrieval. Additionally, Delta Lake's support for streaming ingestion ensures that the data is written in an efficient and fault-tolerant manner. The checkpoint location option is used to checkpoint location is right here. Checkpoint location is used to specify a location where Spark can save the progress and metadata of the streaming query, enabling fault tolerance and allowing the query to recover from failures or resets. All right, so what we're next doing is stopping the streaming query. It's this command right here. And what this is doing, this line invokes the stop method on the stream object, which represents the streaming query. The stop method gracefully stops the streaming query and releases any resources associated with it. And when working with streaming queries in Apache Spark, it is essential to stop the stream when you no longer need it or when you want to terminate the application. Failure to stop the stream can lead to resource leaks and prevent the application from exiting properly. By calling stream.stop or stream stop, you ensure that the streaming query is terminated safely and any associated resources such as threads or or network connections are properly cleaned up. This is a good practice to follow in working with streaming applications to avoid resource leaks and ensure proper application shutdown. All right, and finally, we are reading from a Delta table and writing to console. So what does this last command enable us to do? Stream2 is assigned the value. So let's start with Spark stream format delta. This line creates a streaming data frame by reading data from the delta table located at temp delta table, and the read stream method is used to initiate the streaming read process. Format delta is specifies that the data should be read from a Delta Lake table. Load temp delta table loads the data from the specified delta table path, and then writing the streaming data to console, write stream format console start. This line writes the streaming data frame to the console. The write stream method is used to initiate the streaming write process. Format console specifies that the data should be written to the console's output. Start starts the streaming query and begins writing the data to the console. And the streaming query is assigned to stream2. This is a variable for later reference. And by reading from a Delta table as a streaming data frame, you can continuously monitor changes or updates to the Delta table. This can be useful in scenarios where you want to process data as it arrives or get a real-time view of the data in the Delta table. Writing the streaming data frame to the console allows you to inspect the data as it is being produced by the streaming query. This can be helpful for debugging purposes or for getting a quick glimpse of the data in the Delta table. Note that writing to the console is typically used for testing and development purposes. In production scenarios, you would likely write the streaming data to another data sink, such as another Delta table, file system, or a database. With this, we are done with the quick start. Now, via this quick start, we accomplished the goals that we had said that we would. And coming back to quick start in our Git repo, quick start, we have been able to create a Spark session with Delta Lake. We have, well, we're going over the same content, but we've done all this, everything that our Git repo was telling us to do. We've accomplished all this, and we've done it within the container of a Colab environment, which means that we didn't have to worry about ensuring that we have the right plugins installed, we have the right versions done. Everything was taken care of for us by Colab. So Colab's powerful. Colab notebooks are great. The next notebook's going to be much more involved. I hope this one was simple, and if you have questions, I'm expecting you know questions showing up either on the YouTube video. I think the YouTube video is going to be the simplest place. It's going to enable me to address questions in a way that essentially help other students, and junk will be deleted. All right. Thank you, everyone. It's a pleasure working with you, and I look forward to seeing you on the next one. Here we go. The library is closing.